The chain rule is a method used to differentiate composite functions, that is, functions formed by composing one function inside of another. The most basic formula of a composite function is f of g of x. And then once you take the first derivative using the chain rule, you get the derivative of the outer function, so f prime of g of x, multiplied by the derivative of g of x. We'll start off with some simple examples and build up as the video progresses. So the first step in understanding the chain rule is being able to identify which portion of the function is g of x, or the inner function, and which portion is f of x, the outer function. So say you're given 5x to the third power. So if you're given a function like this, you determine g of x by asking yourself, if I'm solving for an f of x value, right, what do I do to x first? And in this case, you multiply it by 5. So 5x is our g of x value. All right, and then that leaves this exponent of 3, right, what you do after it's multiplied by 5, as that f outer portion of the function. So I'll rewrite the general formula up here for using the chain rule. All right, so we've identified g of x, all right, we've identified f of x. So first thing to do is take the derivative of f of x with g of x unmodified as the argument of the function. All right, so to do this, I'll make this a bit simpler. Let's say we'll let 5x equal u, right, just to make it simpler. So now we see that the function is really just u cubed, right? So if we're looking for the first derivative here, right, this is just a power function. So how do you take the derivative of a power function? We'll use the power rule. So you bring the 3 down to act as a coefficient, 3u, and then you subtract 1 from the exponent. All right, so we get 3u squared. All right, so now we just did that first portion of the chain rule, but now what we need to do is multiply by the derivative of u, or the derivative of 5x, the inner function. Right, we know that the derivative of 5x is just 5. All right, now let's rewrite this. All right, and we will sub in 5x back for u, so we will have 3 5x squared multiplied by 5. And then we can rewrite this a little cleaner. We can multiply this 5 by the 3. We get 15 5x squared as our final first derivative using the chain rule. All right, let's step up the difficulty just a touch with this next question. So say you're given a function such as x squared plus 7 raised to the 8th power, and you're told to find the first derivative using the chain rule. All right, so the first step, like before, is to identify what the inner function is. All right, so what are you doing first to x? So here it's evident, because it's in the brackets, that you're squaring x and then adding 7. So x squared plus 7 is our g of x. It's our inner function. And that leaves this exponent of 8, what we do next, as the outer function. So I'll rewrite the formula again. It's the derivative of the outer function with the inner function kept inside, multiplied by the derivative of the inner function. All right, so now that we've identified the outer and inner functions, we can solve for the derivative. All right, so we'll make it a little easier. We'll say let x squared plus 7 equal u. So we're just saying that the inner function is equal to u. So we can say that the total function, the full function, is just u to the 8th power, right? So if we're taking the derivative here of u to the 8th power, you'd bring down that 8 to act as a coefficient and minus 1 from the exponent, right? That's just the power rule. So we get f of x as 8u to the 7th power. All right, so then that's the first step of the chain rule. But now we need to multiply this by the derivative of the inner function, right? And the same thing can be done with the derivative of the inner function. You just use the power rule on x, right? So you bring the 2 down in front of the x, right? And then you subtract 1 from the exponent, and that would just leave you with 2x. And then we know that the derivative of any constant is just 0, so we don't need to write the 7. This looks messy though, so let's clean it up a little bit. So 8u to the 7th power is really just 8 times x squared plus 7, right? Because we said let u equal x squared plus 7 to the 7th power multiplied by 2x. And then even simpler, we can multiply this 8 by the 2x to get 16x times x squared plus 7 to the 7th power. All right, and that's it. That's the first derivative using the chain rule of this function. Okay, next let's walk through an example with a trigonometric function, such as sine of 3x squared. So similar to the examples before, this is a composite function, right, where we have an inner g of x portion of what we're going to do first to that x value, and then the outer, right, taking the sine of it is what we're going to do second. So write the equation down again. We have the derivative of the outer function with the inner function inside and unmodified multiplied by the derivative of the inner function. Alright, so that's how you use the chain rule. So let's go through it. So the derivative of the outer function would be just the derivative of sine, which we know is cos. Alright, in case you guys don't know, for the three trigonometric identities, these are just derivatives you should remember. But sine's derivative, here, wait, is just cos. Cos's derivative is negative sine. And for tangent, you get secant squared when you derive it. Right, those are just, you should memorize these, right? These are just important derivatives. Alright, so we get cos with the inner function unmodified. Alright, so 3x squared as the argument of the function. And then we'd multiply that by the derivative of the inner function. Right, so that would be the derivative of 3x squared. So you bring down that 2, multiply it by the leading coefficient, right? You just use the power rule. So you get 6x and then subtract 1 from the exponent. So 2 minus 1 would give us 1, but we don't need to write that. So that would be our derivative of the inner function. And that's it. We now have the first derivative of this function here. And we found it using the chain rule. Alright, let's try one more example with the chain rule. We'll step up the difficulty slightly again this time. So say you're given the function f of x is equal to the square root of 5x cubed plus 8. Alright, so whether you see it right away or not, this is still a composite function. Alright, it can be rewritten as 5x cubed plus 8 all raised to the power of 1/2, right? Because that's all that a square root is, just the power of half. Okay? So now it makes it a little more obvious to see that this is our interior function, or g of x aspect of the function. And then our exterior aspect of the function, the f part, is up here. It's the exponent. That's what you do second. Alright, so I'll write up the formula one last time. So the derivative of the outer function with the inner function, right, resting inside, unchanged, multiplied by the derivative of the inner function. Alright, that's the formula for the chain rule. Alright, so we know that the outer function is just this exponent here of half, right? So u to the power of half, it can just be thought of if we let this interior part equal u. So if we do the power rule here, we'd bring down the exponent, right? It acts as a leading coefficient. We'd get, we can just write half as 0.5, u to the negative 1/2, right? Because that's how the power rule works. You subtract 1 from your previous exponent. Then we'd multiply this by the derivative of the inside function, which is just the derivative of 5x cubed plus 8, right? So the real complicated part here would just be to use the power rule, but it's pretty straightforward. So 3 times 5 gives us 15, x, subtract 1 from the previous exponent, squared, and then any constant when you take the derivative goes to 0, so plus 0, but you don't need to write that. Alright, now this looks messy though, so how can we kind of clean this up a bit? So first things first, let's sub in 5x cubed plus 8 as u. We get 0.5 times 5x cubed plus 8 to the power of negative 1/2. Alright, remember too, negative exponents are really, you can just take the reciprocal. So that's what we're going to do here in our next step of simplifying. So really what we would have, we can multiply 15 by 0.5, 15x squared by 0.5, we'd get 7.5x squared divided by, and we could take everything here that's being raised to the negative exponent and put it in the denominator and make that exponent positive. So we could say 5x cubed plus 8 to the power of half, which, like we mentioned before, the power of half is just the square root. So we can really erase all this and just write the square root. Alright, and this is our final answer. This is the first derivative of the function square root of 5x cubed plus 8 that we started with. Alright, to finish off, I've attached 3 practice problems for you guys to try out the chain rule and try to see if you can find the first derivative of these functions. Alright, pause the video now if you want to give them a shot. Alright, and with that, we're going to end this video. Comment down below if you guys have any questions.